1.7, completing the square. So this is an important skill, so please make sure you work on this wholeheartedly. You're going to use it in multiple chapters, so I'm going to walk you through the skill of completing the square, but you definitely need to be good at it. Okay, so let's get started on this. Bam. Complete the square. Lesson 1.7. Yep. So here's our objective and our essential question. Those of you who want to do Cornell notes can go ahead and write that down real quick. Students will be able to complete the square to solve quadratic equations. So once again, we have this quadratic equation that can be difficult to solve sometimes. Lots of times it won't factor. Sometimes the square root method won't be really that easy, so we have to do what's called completing the square. But completing the square does involve doing square roots, so that's the skill that we needed to develop in order to be able to do this. So we're going to see a little bit of that as we go through this. So naturally, the essential question is how is the process of completing the square used to solve quadratic equation? Well, we'll find out. Everybody see that? So completing the square means a number is missing. There's a number that's missing in the trinomial that makes this a perfect square. You see, by perfect square we mean that the exponent is a 2 up here. Okay, so there's a number that's missing. And so we have the A term, we have the B term, but the C is missing. Okay, so to complete the square we need to figure out what this C is. Now, to figure out what the C is, we just need to recognize this pattern that comes up, and we've seen this pattern before. What happens when we do square things out? Like if I have x plus y, what does the pattern look like when we square that out? Well, if we expand this a little bit, we have x plus y, and we have x plus, by the way, you don't need to write this down, you could just, unless you're doing Cornell notes. I'm just going to show you something here. If you FOIL this out, you get an x squared term, right? And then you get an xy. And then we always end up with another one. Another xy. And then finally we end up with a y squared. And so we end up with like x squared plus 2xy plus y squared. Now, I want you to notice that there's a 1 out in front. To complete the square, we always want a 1. And what that means is that when we're thinking about the coefficients here in the middle term, we want to figure out what y is. You see? We want to figure out what the y is. Okay? Now, if you can look at this and look at this, we can kind of figure out what to do. So it's actually real easy. To figure out this number here, all we need to do is divide this one by 2 and then square it. And so, like for example, we'd say, well, 8 divided by 2 is 4. And what's 4 squared? 16. That's the number that you're looking for. So, and it makes no difference if you're subtracting. I mean, the same pattern holds. I mean, if this is a minus, this would have been a minus, this would have been a minus, this would have been a minus, that would have been a minus, and you would have had a minus here instead. And that's how you get the minus here instead. So, regardless of how you get this, you're still going to have a 2xy here. So, to figure out what goes here, it's y squared. So, there's a 2 involved, 2y here. So if you divide by 2, you'll figure out what the y is, and then if you square it, you get y squared. In this case, the x is acts like a 1, because there's a 1 in front. We want the 1. to be thought of as the x that you're after. Okay? Well, so that's the basic idea. So we're looking for a perfect square. So there's the two patterns again. Whoa, let me back up. You see, no matter what, you're multiplying by 2 here. Okay? So I showed you how to do this now. And we find out that complete the square is pretty easy. So you're going to have some problems like this. You're going to have some problems where you actually have to find the c that makes this a perfect square. Well, once you recognize the little trick that you do, pretty easy, right? All you have to do is divide this one by 2, and you get 8, right? And then to get c, you need to square it. And so that number there is going to be 64. Okay? Make sense?
Yeah.
Huh? Well, it's the number that we need to make this a perfect square. What that means then is that this would factor then to x plus 8, the quantity, and it would be a perfect square. But it's not a perfect square right now because it's missing the c term. I mean, it only has this part of this perfect square. Now, you're going to see why we want to do this here in just a moment, but it involves a square root method that we learned yesterday. What we'd like to do is take the square root on both sides. So in order to do the square root on both sides, we do need to make this a perfect square first. So you're going to look, if you look on your study guide, I think there's 3 problems you can do right now.
The first 3?
Yeah, the first 3, because you're asked to find the c. You're asked to find the c. Let's see if we can get this.
You always divide by 2?
Divide the middle term by 2 and then square it. So we'll go down to here, study guide 1.7. Okay, you should be able to do these exercises now. So take a moment, I'll give you about a minute or 2, see if you can find the 3 C's that are missing. No, he wasn't, mister. Okay, so let's figure this out. Let's look at this study guide. Darn it. So all you need to do is divide the middle term by 2 and square it. So you get 6, and then you square that, you get 36. And so your c is equal to 36. Okay, then it says, then write the expression as the square of a binomial. So you would have like x squared plus 12x plus 36. But that's equal to a perfect square now. And so now what you could do is write this as x plus 6, the quantity squared. You see? Now it's a perfect square. That's what you were supposed to do on number 1. Okay? Do you think I need to do another one? Okay? Well, let's do the second one then. Now this one you would divide by 2, okay, and you get 9, right? And then you'd square that. And so it's equal to 81. So that means your c is equal to 81. Okay? And so now let's think about this. Now that you figured out what c is, you could then write this as x squared minus 18x plus 81. But now that you found this, it is a perfect square. So you could write this squared. Now, what goes in here? It's minus this time because there's a minus right here, right? So it's x minus 9. You see? That sort of makes sense? Feel more comfortable with this? I hope so. Okay, so let's return to the PowerPoint now, and we'll go to the next step. Here's a little visual about completing the square and why they call it completing the square. The number that you're after is this one right here. So it's like you have part of a square drawn in, and you're missing this number right here. And that is a visual that shows that you're completing the square. And so over the years, this has been called completing the square. And once you get that piece in there, then this is a square, and that side, all the lengths of this sides are the same. So this is x, 8, 8, x. And so you can see it's a square now. Anyhow, I don't think it's necessary to draw the picture, but if it helps you, you can draw the picture. Do whatever it takes. All right. Now we're gonna show you the method of completing the square, and so I'm gonna show you step by step. All right. So please take good notes on this. Even if you're just doing the study guide, that's fine. Somewhere on that study guide, please copy down this example so you'll know how this. Copy down. Make sure you copy step by step. Okay, the first step when you're doing completing the square is to move the C term to the opposite side. So you're going to move it over to here. Okay, so you subtract 4, subtract 4. Now, this is a little bit different from the procedure when we were using that zero product I did. You see, if this factored, we'd factor it instead, and we wouldn't do this. So keep in mind, every little idea that we learn has its own set of steps. Okay, completing square has its own set of steps. So what we have here, now what I'd like to do is minus 12x here. I like to now put a square right here. Equals negative 4, and I put a square here. Now remember, we're going to add some number, think of it as the C, on this side of the equation to make it a perfect square. What we want is the perfect square right there. Now you've just done 3 problems where you practice finding that C out. And what we're going to do is we're going to add in the C on this side, but remember, when you have an equation involved with an equal sign, you cannot just add the C to one side without adding it to the other side. That's why I drew in 2 boxes. So do me a favor, figure out what the C is real quick on your own and put it here and here. Go ahead, real quick. 15 seconds. 10 seconds. 5 seconds. 4, 3, 2, 1. 0. What do? We divide by 2, right? And you get 6. You get 36 here then. So that's a 36 here, and that's a 36. Everybody good with that? Now that you've done that, you know that this side here is a perfect square. So please figure out what goes here. X minus. How do we know it's minus? The middle term is minus, so we got to keep that a minus. Minus 6, right? Now, let me give you a little secret I learned a long time ago. This is a little secret Mr. Russell learned. You guys want to see my secret? You can tell this is set up right because the C term is sitting right here. Do you see that? It's sitting right there. Okay? So there's a quick way to test whether you have this right or not. You see? It's sitting right there. Now if this doesn't match there, you've got a mistake. Does that make sense? 6 squared, 36. So that matches up right there. Let me take that off there now, because I like my work to look nice here. Now this side's easy, right? 36 minus 4 is 32. Now you should recognize how to do this, because this is what we were doing on section 1.6. we're solving equations by the square root method. So the next step is to take a square root. We do the square root on this side. We do the square root on this side. And since we're solving for x, we need to put a plus or minus over here. And when you take the square root of a perfectly squared number, they're inverse operations, so they cancel. So we get x minus 6 here. And that's equal to plus or minus square root of 32. Now, do you guys see some perfect squares in there?
Yes.
How about 16, right? 16 times 2?
Yeah.
This is 16 times 2, so why not split this up as 16 times the square root of 2? So I think I'll do some more simplifying. I'll use this color. This gives me plus or minus 4 square root 2. The left side is the same. And the final step to solve for x, I just need to move the 6. So I'm going to add 6 here. I'm going to add 6 over here. So I get x is equal to 6 plus or minus 4 square root 2. Now please understand that this is two different answers. If you were to plug this in your calculator, on the one hand, you would use the positive 4 square root 2, and then you'd add it to 6. The second answer, you'd take 6 and subtract 4 square root 2. So you're not going to be required to do this, but I think I'll do it just once. Show you what happens. So if I take 6 and I add 4 square root 2, I get x is equal to 11.6 or so. 11.66. Okay? And if I use the negative one now, like if I subtract, then I get x is equal to, try it again here, 6 minus 4 square root 2. And I'm just doing this in my calculator to find out what I get. And this time I get 0.34. So these are my two answers.
Do you need to do that?
No, you don't need to do this, but I want to do it once to show you what we just did. What we did, because we will be doing this later, we found out something about this quadratic. We found out a little bit about its curve. Remember this number out in front here? This tells you that the parabola opens up or down. And because it's a positive 1, it opens up, right? And if we wanted to, we could find the vertex, right? Remember x is equal to negative b over 2a. That was a previous lesson. Almost seems like a year ago. It was just a few weeks ago, right? Well, what we found out, these two numbers are the zeros. So there's a 0 right here, and then there's a 0 way out here at 11, and somewhere between is the vertex, and the parabola opens like that. So again, what we're doing is we're finding zeros. And earlier in the chapter we had nice equations like x squared plus 7x plus 6. And we set this equation equal to 0 and we solved it by factoring. Remember, we did things like x plus 6 and x plus 1. And then we found out x is equal to negative 6, x equals negative 1. Well, that problem was doing the same thing. It's just this equation factored. And if the equation factors, great, we'll factor it. We can find the zeros real fast. Okay? But a lot of times the equation does not factor, and so we're left to use the square root method or completing the square method. And so this method, as you notice, involves quite a bit more work to get the two answers. You see? Factoring, we're done in 2 steps. and we're done. So completing the square is probably the harder section on this chapter, but it is a skill that we're going to use in chapter 8, and we'll see it multiple times in this course. So you do want to practice this over and over and over again. So now what we need to do is about 50 more of these so you can get good at it. And yeah. Okay, so I think this is a good stopping point right here. And so this part 1 will be done, but I'll do some more of these tomorrow. Okay? You can put your notes away.